Morning class. Today we're going to take a look at geometric sequences. So in our adventure on sequences, we looked at arithmetic for the last couple of days. Today we're going to look at geometric. And geometric sequences, if you look at this sleeve, or this line rather here, of a times r squared, a times r cubed, you'll notice that each term is multiplied by an r. Okay? The common ratio is called r. Okay, so we got a common ratio. We're going to start with the value of a, which is our first term, and that would be the a term. Now, the way that I can look at a geometric sequence is if I take a to the a sub 2 divided by a sub 1, or the second term divided by the first term, should give me r. As should a to the third, or the third term, a sub 2, and so on. So each consecutive term, if you take this, put it over this term, and this one over this term, and this one over this term, each of those should give us r, which is a common r. Okay, so a sub 1 is the first term, that's a, the initial, all right? And the formula that we're going to use, is this one right here. A sub n equals, well, this would be the recursive. Actually, the one that we want to use is this one down here. So let me disregard this one, and we'll take a look at this bottom one. An explicit definition. Any term that you're looking for, a sub n, the nth term, okay, the nth term, so n is the number of the term, a sub 10 if you're looking for the 10th term, a sub 104 if you're looking for 104th term, will be equal to the very first term, a sub 1, that's the initial, times r, that common r value that we said was the ratio, common ratio, to the, and then here's where n comes in, n minus 1 power, for n greater than or equal to 1. If n happens to be 1, we're going to have r to the 0th. But if you have r to the negative value, okay, it's going to screw things up here. All right, so n is the number of the term. A sub 1 is the first term in the sequence. Okay, and then again, n is the number of the term, and r is the common ratio. Okay, common ratio. So there's our three terms that we're going to be looking for. Each of the sequences that we're going to look for, we're going to try to determine what's the first term, what's the common ratio, and then we can go from there to find the nth term. Now, so here's the, got a piece there, sorry. Is the sequence geometric? Well, that's a good question. So look for, is there a common r? Okay, so if I can find a common r, well, here's how you do it. Take 6 over 3, take 12 over 6, take 24 over 12, take 48 over 24. Okay, that's 2, that's 2, that's 2, that's 2. R then is 2, and is there a common r? Yes. So is it geometric? Yeah, it is, because there's a common r. If this was 2, and say this was 3 halves, and this was 5 halves, and something like that, and these were all changing, then it would not be geometric. Okay, but they're not. They're all 2s. 2 and 2 and 2. All right. So let me just get rid of all of that stuff there. All right, so a sub 1. Well, that's the easiest thing to find. It's the very first term. So a sub 1 is 3. So what are we going to use? Well, we'll go back to this formula that's up here. A sub n equals a sub 1 times r to the n minus 1. Oh, wait, we're stopped. We're done. We wanted to know what's the r, common r, and the first term. So there we found them. We'll go on. I was jumping ahead to number 2. Here's another one in the sequence. Is it geometric? Again, 6 over 3, 9 over 6. Okay, so 6 over 3, that's a 2. 9 over 6, that's 3 over 2. We got a problem, Houston. Already we've got an issue. 12 over 9. Okay, that's 4/3. Okay, so we definitely do not have a geometric sequence, so no. Well, it says if it is geometric. Well, since it's not, no, not geometric, then we can't go any further, and that's all we can do with it. Okay, take a look at the next one. Is this a geometric sequence? All right, so 3 to the 10th over 3 to the 5th, 3 to the 15th over 3 to the 10th, and 3 to the 20th over 3 to the 15th. Okay, well, 10 minus 5 is 5, so this would be 3 to the 5th. 15 minus 10 is 5, so this would also be 3 to the 5th. 20 minus 15 is 5, this would be 3 to the 5th. 3 to the 5th is 3 to the 5th is 3 to the 5th, so the common R is 3 to the 5th. Ooh, that didn't come out at all there. 3 to the 5th, there we go. All right. And the first term again, a sub 1, is this guy over here. It's 3 to the 5th. Can they both be the same? Yeah, sure. Why not? Okay. 3 to the 5th, 3 to the 5th. So there's my two terms, and that's what I was looking for. All right, is this sequence number 3? Is this one geometric? All right, so we take 4 over 2. That's 2. We take 8 over 4. That's also 2. And 16 over 8. That's 2. So looks like yes. R, common R, is 2. Okay? So the first term then is this guy. So a sub 1 is 2. And R is 2. And so my answer is A. What's the 10th term? Okay, now 10th term, on this one we're looking for n is 10. Okay? And we got to determine, is this, but it does call it of the geometric sequence. So it already told us this is geometric. So that we know that a sub n equals the first term times r to the n minus 1. Okay? So there's the formula that we got from that first slide. We'll pull that back. So a sub n would be a sub 10, or the 10th term, is equal to the first term, 4, times r. Okay, what is r? 12 over 4 is 3. 36 over 12 is 3. So r is 3. So this would be 4 times 3 to the n minus 1. Well, that would be 10 minus 1, or the 9th. So 4 times 3 to the 9th. Now be careful. It'd be really easy to say, oh, well, that's just 12 to the 9th power. No, that would be wrong. You always have to follow PEMDAS. Exponents would precede multiplication. Something happened there. I got this new pen and a glove that I'm trying to use. Evidently it's moving. So 3 to the 9th power. What is 3 to the 9th power? Okay. 3 to the 9th power, write it on your calculator, is, I can't find my calculator here. Wow. So 3 to the 9th, that's 19,683. And if you multiplied 4 times 19,683, you're going to get 78,732. Okay, so the 10th term, a sub 10, the 10th term is that. Now, if you look real carefully at this, it started out 4, 12, 36. That's the first three terms. And you're telling me that by the 10th term we're clear up to 78,000? Yeah, this thing's jumping fast. All right, it's going very quickly. All right, that's all that we're going to do for today. Your assignment is in Math Excel, and you'll be able to follow along with these problems. We will pick up at this point for Friday.